Now for the very important part of application of derivatives, which is optimization problems. Here you can talk about optimizing the profit, the area of a particular shape, or you can optimize the volume of a particular three-dimensional object, and you can do many things up with the optimization problems, and this is the most important application of derivatives. Okay, there are certain very common problems which are using cone, using cylinders, and there are certain places where you would talk about the rate of change. Okay, this is the main concept that we use in this optimization problems. That is, when one changes, the other changes, the relative rate of change. So what happens when a sand falls through a cone? That is, there is a conical filter, and what happens to the sand inside when the sand comes through the nozzle of the cone? Or when what happens if there is a cylindrical tank and you have a pipe where through which the water flows out, or when you pour in water into the cylindrical tank. So what happens to the volume of the water, or here if for example volume of the sand which is inside the cone, and all these questions come under the rate of change. Also, if I have a circle or a blot of ink which is going to be increasing, it increases in circular form, and what you can see is that the radius increases. So as radius increases, the area of the circle increases. So there is a change in the area, which means there is a rate of change. Any change over a period of time is called the rate of change. So as something changes over time, and that particular question would be coming under rate of change questions. Okay, so this is what we are going to see in this video. Many questions on optimization. Let's consider this as our first example. The number of bacteria n of t. So I can write this as n of t is equal to 1.25 t square 20t plus 980, which is the function given here, and t is measured in hours, which is time, therefore it is always positive. And the first question is, find the rate of growth of the colony when t equal to 4. Now the word rate of growth, which means the derivative of the function n of t. Let's call it as n of t because it's given as n of t there in the question. So the derivative of n of t function is going to be the rate of change of the function. So n dash of t here would be 2.5 t plus 20, and you need to find this at t equal to 4. So n dash of t at 4 would be 2.5 times 4 plus 20, which would be 30. So this is the rate of growth of the colony at the time t is equal to 4 hours. That is after 4 hours, 4 hours after the function has been observed. Okay, now show that n of t is an increasing function. I told you for increasing function, the slope is positive. We have to show that the slope is positive for any value of t. So the value of t is the value of n dash of t, the equation of n dash of t is 2.5 t plus 20, and t is positive. Therefore, this is always going to be greater than 0, which is this is always a positive quantity. Therefore, the derivative is positive. Therefore, it is increasing. Okay, the second question here would be the concentration C mole per liter of a drug in the blood t minutes after being administered is given by this equation. C is equal to B times T times 2 to the power of minus KT, where the T is between 0 and 30 minutes. You know that it is in minutes. How long will it be before the concentration level in the blood starts decreasing? That means usually the concentration is, once you administer, the concentration increases. You start administering and you give more and more of that particular medicine, and then after once it's stopped administered, then it starts decreasing in the blood. So at this point is this is the point which is in the question now. What is this point when it starts decreasing? And obviously, mathematically speaking, we are going to find the maximum point. So it may not be in the straightforward way that you are supposed to find the maximum, but it says when does it start decreasing. That is when it starts decreasing means when there is a when is the maximum point here. So we can find the first derivative and here let's use the product rule. The first one would be 2 to the power of minus kt times 1, and the second one would be you have to find the derivative of this, which would be k times minus k times ln of 2 times 2 to the power of minus kt. So this you can check it over in your presumed knowledge there. So this would be minus t k, the t is here, t, and then you have to write all these things, k ln 2 and 2 to the power of minus kt, and this is the derivative of c, and this is supposed to be equal to 0 in order to find the maximum. So what happens here is 2 to the power of minus kt can be taken common, and this would be t k ln of 2 equals 0. Now this is okay. Now you have t times k times ln of 2 equals 1, and therefore t equals 1 over ln of 2 times k. Okay, it all depends on the k now. So at this point of t you get the maximum value. So is this maximum? We know that it is equal to 0, therefore it has to be a maximum or minimum. Is this maximum? So what you have to do is you have to find the second derivative at, here it is c, at t is equal to this value. So if you find the second derivative of this, you would be getting, and if you simplify you can see that it is t is equal to this value into this. You can check if it is equal to it, if it is negative, or you can use your GDC and you can plug in this particular function into that, into your GDC, and you can find it out whether you actually get the maximum value for this. Now, next question is a body moves along the x-axis with displacement x centimeters. So this is displacement, where x of t is given as a function which is 10 times t minus ln of t plus 1. And obviously the value of t is positive because it's the time and it's in seconds. Find the object's velocity. So what is it? What is velocity? Velocity is for those who are not physics students, velocity is change or change in distance over time, right? So it is like ds over dt. That is when you have x dash of t, then you get the velocity. And there is acceleration. Acceleration is rate of change of velocity, which means this is, if you have this as v, this is dv over dt is your acceleration, or since it is the derivative of ds over dt, you can also write acceleration as second derivative of the distance function. So you can say that the second derivative of the distance function would be acceleration, and these are the two main important things that you need to know for regarding the kinematics problems under application of derivatives. Now you need to find the object's velocity and acceleration when after being in the motion for 1 second, that is when t equal to 1. So that's as simple as that. You just put them all into mathematical notations and it's easy for you to understand. What is x dash v? And I think you can continue doing this, finding the derivative 1 minus 1 over t plus 1. And you need to find when t equal to 1. Obviously it is 5. And what is the second derivative, which is acceleration? So just find the derivative of this. 10 times, it's 1 over t plus 1, which would be t plus 1 to the power negative 1, which would be negative 1 over, which is already negative, therefore positive 1 over t plus 1 the whole square. Now again, when t equal to 1, this value is going to be equal to 10 over 4. And you cannot stop this with this answers, you have to give them as with units. So x dash of t is actually velocity. So the units used here is centimeter and seconds. Therefore, this is centimeters per second. And for acceleration, it is centimeter per second square. Next question is a particle is projected vertically upwards in such a way that it experiences resistance. Don't worry about all those things if you are not a physics student. So that its height in x meters and t is in seconds, and its height is given. The function is the height, actually the height, which is the distance. You can take it as a distance here. Height is given as this much. Okay, minus 20t, where t is positive as usual. Now a particle is thrown up. So what happens is it goes up and it comes down. So you can see that at this point the velocity is going to be 0. So at the maximum point the velocity is going to be 0. These are small things which in physics which you need to know in order to apply derivatives into these questions. So you need to see which t is x dash of t equal to 0. I think that's going to be very easy now that you know what application it is. Just find the derivative of this function and substitute, make it equal to 0 and find the value of t, and that is the when part, which time, and be sure that you write the units there. Okay, so the next question would be a particle moving along a straight line has its displacement x meters from displacement x meters. These are the things that you need to concentrate when you're reading through a question, and very important, please read through the whole question word by word, and maybe you can underline these important things and when you are reading through them. From a fixed point at t seconds, and the distance is given by this equation: x is equal to t cube minus 17t square plus 80t minus 100. If you are confused with the x equal to, then you can just write this as x of t equal to a function of t equal to so much, or you can simply write f of t equal to so much. Since x is used here, it's better you use x of t. Find the particle's initial position. Its initial position is when t equal to 0, which would be minus 100. So its particle's initial position is minus 100 meters. That is to the left of the origin. So if your origin is somewhere like this, it's starting from at this point, which is 100 meters away from the origin towards the left side. How many times will the particle pass through the origin? So how many times it will be equal to 0? When the particle is at the origin, the distance is 0. When the particle is on the right side, its distance is positive. So the question is, what is the value of t for which s is equal to 0? This is question number B. So you can just make this equation to be equated to 0, and you can solve the cubic equation. If you can access the calculator, you can easily find it from that. Next, let me pass on to question C. Find the particle's initial velocity. You know, velocity is the derivative of the displacement. So the derivative here would be 3t square minus 34t plus 80. So this is x dash of t, and you are asked to find the particle's initial. Initial always means t equal to 0. So at t equal to 0 is what you are supposed to find. X dash of t would be 80, and remember to write the units here, meters per second. The next is acceleration. Simply you need to find x double dash of t. X2 dash of t would be first 60 minus 34, which would be minus 34 now, and meters per second square. This is for x is t equal to 0, that is initial acceleration. Question D, find the particle's maximum displacement from the origin for time between 0 to 10. Particle's maximum displacement, that is, you need to find, this is the displacement, so you need to find the maximum value of this maximum displacement as such, that is maximum x in this interval. So first you need to find the values of t for which the x of t is maximum. Okay, so that is our question now. So how do you find that? For that you need to put x dash of t equal to 0, which is, we have it here, which is 3t square minus 34t plus 80 equals 0. And you can simplify this, and then you will get the value of t to be equal to, so this is the value for t for which this equation is equal to 0. And you cannot stop here. The question is, what is the distance, maximum distance, displacement? So you need to find x of t. So you need to find the maximum value of x. That is, you need to substitute the t value in the equation for x of t, which is t cube minus 17t square plus 80t minus 100. When you substitute 10 over t into t, the value would be 14.81 and something. You can round off to two decimal places. So this is the maximum displacement. So if you forget to do this, then you will lose some 2 or 3 marks for that. So this is per second, and this is meters. This is the unit for t is seconds, and unit for the displacement as given in the question is meters, and this is your final answer. Now the next question is on the area. The radius of a circular oil patch is increasing at the rate of 1.2 centimeters per minute. So as you can see, this itself is the rate. So which rate is it? It's radius. Therefore this is dr dt. So you just rewrite the question into mathematical notation. Find the rate at which the surface area, if I use the surface area notation as a, find the rate at which the surface area, so you need to find dA dt, is increasing when the radius is 25 centimeters. So you need to find dA dt. For that you first need your surface area of a circle, the area of a circle, circular oil patch. So it's a circle. So area of a circle is pi r square. So this is something that you have to get it from the question. It's not given in the question, you have to make it. And then the thing which you want is dA dt. So if you can use your chain rule, this is dA dr times dr dt, which is 2 pi r times dr dt. Now you need to find dA dt at r is equal to 25 centimeters, where dr dt is given. So it's very simple. This is dA dt, and just substitute the value of r here. Do not substitute it in this place. It's not, you are not supposed to substitute r equal to 25 here. You are supposed to substitute it only after differentiating it. At the final point is where you are substituting the value of the radius here. So 2 pi 25 times dr dt is 1.2. You can simplify this further as per the question if you want, if you can leave the pi as it is, or you can give it in decimal points. Okay, I hope you understood how to do this type of problem. The main thing is you need to make up this according to the question, and then you need to know what is asked and what is given. Now let's do one more. It's on volume of a cube. So what is volume of a cube? It's, if you have x as its sides, it's x cube. It's increasing, so you are given the rate of increase of the volume dV dt, which is 24 cubic centimeter per second. It's given. So you, even by looking at the units, you know what is given. Cubic centimeter per second is dV dt. Cubic centimeter is volume and second is t, therefore it is dV dt. At what rate are the sides lengths, that is, what rate is the length of the side increasing or decreasing, whatever, here it is increasing, when the volume is 1000. Now you are not supposed to consider this at this point. You should substitute V equal to 1000 only in the last step. So now what is V? V is x cube, and this next step is find dV dt. Just write the volume, which would be dV dx times dx dt, and I can write it directly like this. So at this point you need to substitute the value of V, volume is given, and what is dx dt, or whatever is given and whatever is asked. Dv dt is given, and dx dt is your question. Now you need to manipulate this, the values here. Now this is something what we want. Which one? The dx dt, and this is given. Therefore you can substitute dv dt, which is 24 here. So 24 is equal to 3 times, we don't know what is x because v is given as 1000. So when v is 1000, x cube is 1000. Therefore x is 10. So you need to get x values from the given volume value. So 3 times 10 times 10 square times dx dt is what we need. So dx dt equals 24 over 300. You can simplify as per the question. Okay, and here don't forget to write the unit. The unit is centimeter per second. Another question is, container is in the shape of a right circular cone. This is a very important question because a cone question has some real manipulation to be done. A container is in the shape of a right circular cone. Okay, and the base radius is 10 centimeters. So this is 10 centimeters. It has and the height is 50 centimeters. Has water poured into this. You are pouring water into this, so you can see that you have some water in this, and the rate of the flow of water is 5 cubic centimeter per minute. So it's obvious that you are given dv dt is 5. So just by looking at the unit you will know what it is. Find the rate at which the level of the water, if I call the level of the water as h, so you need to find what is dh dt. So why did I tell that this is a special case? Don't worry about this. This is something that has to be substituted at the last. So here in cone problems, as the water starts increasing, as you pour in water, you can see that the level of the water increases like this. It goes on increasing. The surface of the water is a circular surface which increases both in radius, and the level of the water also increases. So the height increases and the radius increases. So if you have a right circular cone like this, and this radius, the cone's radius is fixed and the cone's height is fixed, but when you are talking about the water surface inside the cone, it changes. So this height changes and the radius changes. But what you can have here is you have two similar triangles, which is one is here and the other one is here. So these two triangles are similar, and therefore you can compare the values, the components of these two cones, which is radius over height. The first is 10 over 50, and the radius is r, and the height is h for the smaller one, therefore r over h. In this way you can actually rearrange h and r as you wish, because there are two things that are changing. In the previous case you had a circle which was changing, but there was only one component, so there was nothing much to worry about. When it was volume of a cube, it's only one side which was changing. So in the previous cases only one component was changing, but in problem like cone you have two components which are changing, both r and h. Therefore you have to be a little bit careful about it. So we are given the volume. So the first thing is just take what is volume of a cone, 1 over 3 pi r square h. So you need to find dv dt because it's given. So, and you need to find dh dt. That's the question here. You are given dv dt and you are supposed to find dh dt. But what is this r doing in between? But it is not a constant because r is changing here. Therefore you can't just leave the r there. It has to be rearranged and this has to be changed. This formula can be used. Say r is equal to 10 h over 50. So I can rewrite r in terms of h. So this would be 1 over 3 pi, I can write it as 1 over 5 h square over 25 times h, which would be pi over 75 h cube. So this is our new formula for v. In that case dv dt would be pi over 75 times 3h square dh dt using chain rule. And now going back to the question, this is what we are supposed to find. and this is equal to 5 dv dt, and the h is given as 10 centimeters. So this is equal to 10. So substitute these values and find what is dh, rearrange them and find the value of dh dt, and remember to give the units for that, which is centimeter per minute. Be careful in the units. Sometimes this height could be given in meters. In that case, you have to change it to centimeters and substitute, or the rate could be given in some other unit. You have to be careful with the units in this type of problems. Another important question: a ladder 8 meters long is leaning against a vertical wall. So you have a wall and you have a ladder which is 8 meters. Again, be careful with the units right from the beginning of such questions. If the top of the ladder is slipping down, so it is slipping down in this way, that is, this is coming down from the wall at 0.4 meters per second, that is, the top of the ladder is coming down, so this height is changing. So if I call this as h, now dh dt is 0.4 meters per second. How fast is the bottom of the ladder? Bottom is here. So how fast is this going? Or actually, if this is coming down, this will be going away. So how fast is this point moving away? If I call this as x, so I'm actually asked to find what is dx dt. When the bottom of the ladder, this again we will come back to this at the last moment. So what is exactly that you are looking here? This is constant. So we can use Pythagoras theorem here. X square plus h square is always equal to h square. So in order to use the derivative function here, you want dx dt, so you can make x the subject of the equation, and then you can see that 2x dx dt equals minus 2h dh dt. Now going back, what is given? The ladder is 3 meters from the wall, the bottom of the ladder. That means x is given. The bottom of the ladder is 3 meters from the wall, which means x is equal to 3. So what about h? You need to substitute in here as 3 square plus h square equal to 8 square. What is the value of the h at the point when x is equal to 3? So you can easily find out what is h. Once you find the h, substitute the value here and substitute the value of dh dt to be 0.4, and then you can find the value for dx dt, and that's how it is supposed to be done. One more question: a box is to be constructed in such a way that it must have a fixed volume. Volume is fixed and a square base. That means you have a square base. Maybe you can call this as x, but it's nothing is given about the height, so there is a difference in the height, say h. So the volume is always 800 centimeters cube. If the box is to be open ended at one end, so on the top maybe this is open and it's only here that we have the base. Find the dimensions of the box that will require the least amount of material. If the box is to be open ended at one end, so this is the open end, they can keep this as open end, and this is the base of the box which is not open. Find the dimensions of the box that will require the least amount of material. The amount of material is actually the surface area. Okay, what is the least surface area? That is, what is the minimum surface area? For minimum surface area, what is x and what is h? That is the question. What are the things that are given? You have volume and you need the surface area. What is the volume of this particular box? You can see that this is x square h. What is the surface area of this box? Which is should be the base, one base, therefore 1 x square, and then there are 4 x times h. So this is the surface area of this box, because so this is actually given as 800. Therefore what you do is either you take x in terms of h or h in terms of x, whichever is possible, so that this will be having only one variable, say x. So if I have h is equal to 800 over x square, then your s would be x square plus 4x times 800 over x square. And this, from this you need to find ds dt, for which it is equal to 0, and find the value of x. For that value of x, you see if the second derivative is positive because you need S minimum. If this is positive for this value of x, then x, whatever value you got, is going to be the final dimension that you are getting. Substitute this value of x in this again and find the value of h. So you are finding x and h in order to find the maximum, the dimension for which the surface area is minimum. So you are finding equal to 0, and you are proving for that particular x value the second derivative is positive, and then that x value would be your answer, and then substitute that x value in the volume given, and then you can get the corresponding h value. So this is the derivative of s. Putting it equal to 0, you will get x to be equal to cube root of 1600, and then substitute this x value in your second derivative, which would be 2 my plus 3 times 3200 over x cube, and substitute this here, and then you can see that this is positive. After that, you go back to x square h is equal to 800, and put the value of x in here and find what is h.